I'd like to present to you how our team tackles an important challenge in hospitals, which is continuous patient monitoring. And why is this important? Well, hospitals suffer from understaffing and other systematic issues. And while I can't go into detail why that happens and how that happens, at least I can try to share with you a real example. So for example, a patient got out of bed at 5 in the morning. They collapsed by the bedside from a heart attack, and they weren't discovered until like 6:30 in the morning, which by that point was too late. So therefore, our goal and motivation is to prevent such incidents by providing this continuous monitoring solution. So what did we do? Well, basically, there were two main challenges in the beginning. The first one was the respect for privacy and staff. So therefore, cameras are a no-no. And the ease of integration into the existing hospital IT infrastructure. So cables are a challenge there. So therefore, we developed a special low-resolution sensor fusion battery-powered device that accomplishes this. And this device is, or this sensor fusion device is comprised of time-of-flight measurements, which means measuring distance, thermal measurements in an area, movement detection, and other environmental sensors, which basically abstracts the scene into a few pixels that are enough to extract useful information, but not enough to single-handedly say who is who. So like you cannot identify individuals. So like as you can see in this like real data example, these individuals cannot be interpreted or cannot be identified. Sorry. The training approach for us was a bit unique. In essence, we had to use two models. First, we developed a camera-based model in controlled simulations, and then we used this camera model together with the sensor data, both synced to train a sensor model. And then when the sensor model is deployed, it doesn't require the cameras. But of course, every hospital is different. So like sensor placement is different, room layouts are different, staff workflows are different. And so for this, we created a real hospital room as close as possible in our offices where we could simulate scenarios, gather the necessary data, throw this into DCP pipelines where we can label, train, evaluate the models, and this way we can try and scale or generalize our models. And for this system, we have several use cases. So from fall detection to early delirium onset indicators to even hand hygiene. So the key takeaways here are privacy by design by using low resolution sensors, AI for interpreting the sensor data or the challenges that arise there from the low resolution sensor data, and the environmental adaptation, so simulation. And in general, broadly saying that this workflow can be adapted for other industries and scenarios. So like, for example, think retail analysis or industry safety monitoring.